Hello students, welcome to the class. In our last session, we discussed about examples of chemical change. Right? So these are the examples of which we discussed. That is, explosion of fireworks, tarnishing of silver, lightening a match, chewing or digesting food, rusting nail. Now I'll try in this session, I'll elaborate few more examples of a chemical change. Like this. In this slide we're seeing that when a sugar is dissolved in water, as we have discussed, dissolving is a physical change. Okay. Now what are we getting when sugar is dissolved in water? We are getting a sugar solution. What is happening to the state of sugar? It is changing. What is happening to its chemical composition? It is not changed. That is, it is sucrose only. Now what is the formula of sucrose? Sucrose has 12 atoms of carbon, 22 atoms of hydrogen and 11 atoms of oxygen. So on dissolving sugar, there is no chemical change, no in the composition. So it is a physical change. Now, when I am heating that sugar solution, right, then what will happen? When I am heating it, what we'll get is a concentrated sugar solution, which is used in sweets, right? Now, does this chemical composition of sugar changes? No. But the state of sugar changes. It is changing from solid to liquid again. So, what type of change it is? It is again a physical change. Okay. Now, when I am adding concentrated sulphuric acid to sugar, what will happen? You all must have seen sulphuric acid in your chemistry labs. Now, this concentrated sulphuric acid is a dehydrating agent. What do you mean by a dehydrating agent? The word here is de and hydra. What do you mean by hydra? Hydra is something related to water, right? And D means take out. It means what is sulphuric acid is a dehydrating agent. That is a chemical which takes out water is called as a dehydrating agent. If the sulphuric acid spills on the skin, what happens? You get burning sensation, there is a blackening of the skin. Now why it happens? Because what this sulphuric acid does is, it takes out water from that particular part of skin. Okay? So, what it will do to sugar? It will take out all the water molecules from sugar. Okay? Then what will happen? If when water molecules are being taken out, how these water molecules are released, there have to be certain bonds which are broken and the new bonds being formed. Okay. In a sugar molecule, how this molecule is arranged is, carbon, hydrogen and oxygen are arranged is, they will be arranged like in a chain. Say you have this carbon bonded to another carbon, bonded to another carbon, then this carbon is bonded to hydrogen or it is bonded to hydroxyl group. Now if I am adding water to it, what will happen is that this H will cleave from here, bond with OH and it will form a water molecule. So what all is happening here, children? What is happening is that your hydrogen and hydroxyl groups have been cleaved, that is, bond is broken and water molecule is formed, that is, bond is formed between hydrogen and OH group. So, what type of change is it? It is a chemical change. Now when a bond is broken, what will happen? There will be heat evolved. Fine? When a bond is formed, what will be there? That is, that particular energy is used. In this case, the energy evolved is much more than the energy used for formation of water. Got my point? Now what is happening? Water has been removed out from the sugar, then heat is also generated. So what will be formed is, you'll get a black mass, right? Now that black mass is what? Carbon. In the sugar chain, what all was there was? There was carbon, carbon bonded to hydrogen, hydroxyl, and hydrogen and hydroxyl. Now when all the water molecules have been, or all the hydrogen has been removed, what all you will get is, what are you getting is, you are getting water. Okay? So, here there is a chemical change. Right? Now, can we get sugar back from the carbon formed? No. By any means, we cannot get our sugar back from that carbon formed. Right? So, this is again a chemical change. Okay? Now, moving to our next slide, there is another example of chemical change, that is burning of wood. We discussed in our last session that wood is made of hydrocarbons. Now what are hydrocarbons? Hydrocarbons are hydrogen, oxygen and carbon. Right? These are bonded and they make hydrocarbons. Now give me a few examples of hydrocarbons, because you will be doing in your next chapters. These are methane, ethane, butane, or propane. All these compounds must be new to you, children. Don't worry, we have another separate chapter of hydrocarbons. Now you just keep thing in mind that these are present in wood, or these are present in your oils, or petrols, or diesel, or your LPG. All are composed of hydrocarbons. Now in this hydrocarbons, as again carbon, hydrogen, oxygen is present, what is happening to it when it is being burnt? That is, it is again breaking to form carbon dioxide and water. That is, these are the simpler molecules. Now can we get our wood back from that carbon dioxide and water? No. You are using petrol in your water bikes. That petrol also has hydrocarbons. While riding a bike, what are you doing? You are burning that petrol, or that petrol is undergoing combustion, right? Now, after combustion, what are formed as carbon dioxide and water? Can you just get your petrol back from that carbon dioxide and water? No, right? Your mother uses LPG for cooking, right? That is LPG, that is also gas, that is a source of energy which is being used in every kitchen. That LPG has again got hydrocarbon. So that hydrocarbon, when you lit the flame, what happens? That hydrocarbon again cleaves into carbon dioxide and water. Can we get that LPG back? No. So burning of anything is a chemical change. What is happening is, chemical composition is changing, right? So now we have discussed enough of the examples of physical and chemical change. Let's now see what is the difference between these changes, or let's compile the differences between these changes. Now in physical change, what is happening is, no new or different substance is formed, right? That is, when we are forming ice from water, no new substance is formed. When you are crushing a can, no new substance is formed. When you are cutting a tree, no new substance is formed. Got that point? Now chemical change. What is happening here is, there is at least one new substance is formed. It means you are getting at least one new substance. For example, you are burning a candle. What are you getting is carbon dioxide and water. That was not originally present in a candle. Right, children? On burning wood, what are you getting is carbon dioxide and water again. That is a new substance. That was also not present in the wood. Got my point? So, That is, you have seen the example of adding carbon H2SO4 to sugar. So, was carbon present in sugar? It was, but it was bonded. It was not a charred carbon, that black carbon mass. So what is happening here is, there is one new substance formed. Now physical change. It is a temporary change. Temporary means, say, you have taken solid carbon dioxide. There is solid carbon dioxide. Right? Now this solid carbon dioxide sublimes. What do you mean by sublimation? Sublimation is a process in which solid changes to the gaseous state. Now if I warm this solid carbon dioxide, or if I heat it, what will happen? It will straight away change to its gaseous state. Getting my point? Now the state is being changed from solid to gas. But does the composition of carbon dioxide changed? No. Carbon dioxide still has carbon and oxygen, and the bonds are the same. The only difference is, in solid carbon dioxide, those molecules were compact. They were closely packed. But in gaseous carbon dioxide, they are far off from each other. That's it. Again you will cool it, you can get your solid carbon dioxide back. Right, students? Now in a chemical change, it is a permanent change. What do you mean by permanent? Permanent means you are not going to get back your original substance. Right? Say I have discussed that when I mixed sodium hydroxide and HCl, what I got was salt and water. From that salt and water, can I get my sodium hydroxide back? No. I'll have to again mix that. But from that I am not getting. Or take another example of sugar itself. What we did was, we added sulphuric acid and we got a charred carbon. From that charred carbon, can we get sugar back? No. So that change is a permanent change. Right? Say a copper vessel. You know, when you keep these copper vessels for a long time, there is a thick greenish layer deposited over it. Right? Now what is that layer of? That layer is of copper carbonate and copper hydroxide. This we'll be discussing later also. That a particular compound is formed there. Now to shine that copper vessel, utensil, what you do is just scrub it. Right? Just scrub it. What happens? That layer removes off. But can you get that particular copper which has been removed out back? No. You can't get it back. That particular amount of copper has been removed out as copper carbonate or copper hydroxide. Right? So it is a permanent change. Slowly, if you scrub copper daily, you make it shine daily, say within few years, or say later on, depending on the thickness of copper, it will get holes in it. You'll get holes in it. The layer of the metal will get thinner and thinner and thinner, because copper is being removed out as copper carbonate. Got my point? So it is again a chemical change. Now physical change, it can be reversed. Now here I must say that in most of the cases, it can be reversed if I change the conditions. Say I can get liquid water from ice, or I can get liquid water from vapors. If I am changing the conditions, that is, if I am freezing ice, what am I getting is ice. If I am freezing water, what am I getting is ice. Right? If I am boiling water, what am I getting is vapor. Vapor is condensing back. What am I getting is water. Right? Ice is melting. What am I getting is water. So in most of the cases it can be reversed. Say if I have tore a paper into very, very small pieces, can I get my intact paper back? Of course I'll get, if I stick it with a Fevistick or some glue, I'll get it. But can I get that finished product? No. If I have broken a piece of wood into small pieces, can I get that intact finished wood back? No. I'll have to put some glue, then I'll put some paint and all those things, right? So it can be reversed. The physical change can be reversed, but in some cases it is not possible, right? Now in a physical change, whereas in your chemical change, it cannot be reversed at all. Any chemical change can't be reversed, right? Under any condition. A charred carbon cannot be converted into sugar, whatever you do. Whatever are the reaction conditions, your charged carbon cannot be converted to sugar. Got my point? Now, your physical change, there is no change occurs in the mass of substance undergoing the change. What does this mean? That the mass of substance remains the same. Say, students, if I have a torn paper and an intact paper, the mass would remain the same. Or if I have got this 2 kg of some intact cheese cube, okay, then I have got this 2 kg of cheese intact. If I cut down it into small pieces, what has it undergone? It has undergone the change in shape, the change in size, right? But the mass of both of these cheese remains the same. Getting my point? The mass has not been changed. What has changed is its shape. Okay. Now, whereas in chemical change, what is happening? Mass of the individual substances that undergo change always either increases or decreases. That is, the mass of the substance doesn't remain the same after a chemical change. We took example of sugar. What was happening there? That your sugar is being broken down into carbon dioxide and water, or it is forming a charred carbon. The mass of sugar and the charged carbon is different. But if we take together, that is the mass of sugar and the mass of carbon dioxide and water, all together they remain the same. But the individual substances have different masses. If I burn a log, fine, that has got some specific weight. Let's take it's 5 kg of log. Now if I am burning it, it is broken down into that charcoal. Will that charcoal weigh 5 kg? No. Because the water present in the form of hydrogen and oxygen in the log has been evaporated. Getting my point? So that particular charcoal has a lesser weight than log. Right? So in a chemical change, the mass of the substance either increases or decreases. But always remember one thing, that the total mass remains the same. There is no loss of mass. If you sum up like this, that is mass of log is equal to mass of, I'll write down here, that is mass of log is equal to mass of charcoal formed plus mass of water evaporated. Got my point? So, the total mass remains conserved. But if I check out the mass of charcoal, it is decreased. Right? So this is about the differences between physical and chemical change. Now let's discuss why these chemical change occurs. As I have told you, this occurs due to the breaking down of bond or the formation of new bonds. So we can say that a chemical change is equal to a chemical reaction. Okay? Now what is a chemical reaction? It is a process in which original substance loses its nature and identity and form new chemical substances with different properties. Got my point? That is, say original substance. Let's take the original substance, that is your, let's take this LPG, okay? That is LPG. Now tell me, what is LPG? LPG is liquid petroleum gas, right? Now when I am heating this LPG, what I am getting is, I am getting carbon dioxide and water. Okay. Now what is your original substance here in this example? LPG. Liquid petroleum gas. What are you getting after combustion? Carbon dioxide and water. That is, this explains your definition. That is, the original substance loses its nature and identity. Your LPG is a gas, has hydrocarbons, it has lost after combustion, and forms a new substance with different properties. What are the new substance formed? Carbon dioxide and water. Now this carbon dioxide has a different property and water has also a different property. So is a chemical reaction. Now let's check out what happens in chemical reaction. Okay. In the chemical reaction, one element is not changed into other, but rearrangement of atoms take place. What do you mean by this? That is, the chemical nature has not been changed. That is, if I am treating sodium with water, I'll just write it properly. When I am treating sodium with water, what I'll get is, I'll get sodium hydroxide, okay, and hydrogen. I'll get sodium hydroxide, right? Now, what has happened? This sodium hydroxide has got a complete new identity, okay? Now, is it that your sodium has been changed to some other metal, say potassium, lithium, magnesium? No. Sodium is sodium. Hydroxide, you have got OH there. Got my point? Now, when you have got OH there, that is OH is the part of water. Right? Now, you have this chemical identity has not been changed. So, does it mean that sodium has not been changed? Water has got hydrogen atoms and oxygen. These atoms are also not changed. Right? So, what has actually happened? That the element is not changed. Element has not changed into another. What has happened is only rearrangement of atoms take place. Okay? Now let's see, take another example. That is another thing. That is, the chemical substance taken originally is called reactants and the new chemical substances formed are called products. In our example, what we had taken was sodium chloride. Now here, what is sodium and water? These are the reactants. What is sodium hydroxide and hydrogen? These are products. So, these are reactants and products. Now our next point is bonds between the atoms of reactants are broken to form new bonds between rearranged atoms of products. Let's move to our example. That is the bond between hydrogen and oxygen in water. Now what type of bond is present between oxygen and hydrogen in water? It is H, O and H. Now these bonds are broken and it is forming a new bond, that is with sodium, oxygen and hydrogen, and our hydrogen is released. So students, what is happening here is that the bond between your hydrogen and oxygen is broken here and a new bond is formed between sodium and oxygen. And one of the hydrogen has been released out. So this is a chemical reaction. So students, in this session we have discussed about chemical reaction. In our next session, we will discuss characteristic features of chemical reaction. That is, how do we know that a chemical reaction has taken place? There are certain reactions which proceed with the evolution of gas, or some proceed with precipitation, some proceed with a color change. Right? As it is taking place in a molecular level, we can't just go and check out for every molecule what is the product formed, what was the reactants. What we have to do is, we can just check for certain features or characteristics like whether gas has been evolved, or whether there is a chemical change, or there is a temperature change, or there is some precipitation. Right? So we will discuss this and also about a chemical equation. How a chemical reaction can be represented in the form of a equation. Okay, every time you can't write that your sodium hydroxide is reacting with water and forming sodium hydroxide and H2. Right? Sodium is reacting with water forming sodium hydroxide and H2. You can't every time write that. You need to have a one-liner equation. So we'll discuss about chemical equations. Fine? Okay.